Here we go. Welcome everyone. This is lecture number 11 and we are dealing with lenses. In the previous class, we had seen the formation of image by a lens. We had seen the different positions of the object and different positions of the image that are there. No one is going to ask you the ray diagram. Trust me. That is not a question that will going to come in your JEE. Might probably be coming in your board exams. So having taken that step, we are now coming to the next step, which is known as the lens maker's formula. Now again, the derivation of this is not a part of JEE syllabus, so we will not be doing that derivation. We will be straight away jumping into the formula for the lens maker's formula. We will be straight away doing the lens maker's formula. Do we have any idea how does the formula look like? The lens maker's formula. Anyone has seen that lens maker's formula? Any idea? How does the formula look like?
1 by V minus 1 by U is equal to 1 by F.
No, beta, that is not the lens maker's formula. That is not the lens maker's formula. The formula that we are going to study is the lens maker's formula. How do I get the lens maker's formula? Okay, so the lens maker's formula is given in this fashion. So write the heading lens maker's formula. Write the heading lens maker's formula and note down the formula. Lens maker's formula. Lens maker's formula, and the formula looks like this: 1 by F is equal to mu minus 1 into 1 by R1 minus 1 by R2. This is what we call as the lens maker's formula. You must be wondering what is R1 and R2. So if you have this, as your lens and the object is here. Now remember, this R1 and R2 are basically the radius of curvature of the two surfaces which are used for refraction. R1 is the first surface. Right now, if the object is on the left hand side, this is your R1 because this is your surface 1 and the radius of curvature of this surface will be taken as 1. Do we understand this?
Yes, sir.
This would be the first surface. If object is on here, the first surface from which refraction takes place is the first surface and the radius of curvature of that surface is known as R1. If this is the first surface, then the other surface becomes your second surface. This is the surface from which the second refraction is going to take place, and therefore this becomes your second surface. Do we understand this? Now this lens maker's formula here, mu is the refractive index of the medium with respect to air. The better way to write this lens maker's formula is to write it with respect to the medium surrounding it. So if I write it like this, it actually means the focal length of the lens in air, because this is the refractive index of the medium with respect to air minus 1 into, let me take this out, let me put the object here, into 1 by R1 minus 1 by R2. So this represents the lens formula in air. Do we understand this? Lens formula, or the focal length of the lens if the lens is placed in air. Instead of writing it as m here, let me write it as mu of the L standing for the lens, because m I might use for the medium. So this is the focal length of the lens in air. Do we understand this? Yes or no?
Yes, sir.
Remember, this formula has to be used with proper sign convention. And where is this sign convention going to be used? It is going to be used in the values of R1 and R2. Now, looking at the diagram that I have drawn, my object is on the left hand side. Apply the correct sign convention and tell me what is the sign of R1. Is it positive or negative? Remember, your object is here. Your object is here. Tell me the sign of R1. Is it positive or is it negative?
Negative, sir.
Negative,
R1.
sir. Negative, sir.
Negative,
sir.
R1. Look at the object and see what type of surface is R1. And then give me the answer.
Positive, sir.
R1 is positive. Well done. The object is placed here. The convex side is facing it. What about R2? The sign of R2.
Negative, sir.
R2 is negative. So R1 is positive and R2 is negative. There is one more negative with R2 because it is minus. So both of them will get added up, and therefore the focal length of this lens will come as positive, and therefore this becomes a convex lens. Do we understand this?
Sir, where is R1 and R2 present, sir?
Yes, beta?
Where is R1 and R2?
Where is R1? What?
I think R1 is negative, sir.
No, why it is negative, beta? It is convex surface. Why it is negative? Why do you think so? What makes you think that R1 is negative? R1, this is the first surface. The direction of ray is from here. Its center of curvature is somewhere here. How is R1 negative? How? You can think anything better, but there must be a reason behind it, right? This is R1. How it is negative? Tell me. It is in the direction of ray. How is it negative? Tell me. Do we understand? R1 is positive. It is convex.
Yes, sir.
Okay. Everyone get this? Remember, this is the refractive index, or this is the focal length of the lens in air. Now, can I write a similar formula for focal length of the lens in a medium of different refractive index? What would be the formula if the medium is changed and I have a different medium? Think about it. I hope you understand the formula in air. I will repeat the formula in air. 1 by FL or 1 by FA, focal length in air, will be equal to mu of the lens with respect to air minus 1 times 1 by R1 minus 1 by R2. This is the formula of, or the lens maker's formula for focal length of the lens in air or with respect to air. Now, if I have this lens surrounded by a medium, what would the formula be? I'll give you 1 minute to think about it. If it is surrounded by a medium of different refractive index, what would the formula be? Yes, bacha? Tell me, what would the formula be if it is surrounded by some other medium?
Mu of L with respect to m minus 1 into
That-
1 by R1 minus 1 by R2.
That is correct. Well done. 1 by Fm focal length in the medium, surrounded by the medium, in fact, will be equal to mu of the lens with respect to the medium minus 1. This thing remains same, 1 by R1 minus 1 by R2. These small things, if you remember, are going to make a hell lot of a difference in your final result. This is the refractive index of the lens in a medium, and we can see it depends on a very important factor, and that important factor is refractive index of the lens with respect to the medium. Do we understand this? And therefore, if I change the medium in which the lens is kept, we can have different type of lens in the medium as compared to the air. So a convex may become concave, a concave may become convex. Do we understand this? Yes or no? No or yes? Huh?
Yes, sir.
Now I can take the ratio of both the things and tell me what will be the ratio of focal length in the medium divided by focal length in air. What will the ratio come as? Focal length in medium divided by focal length in air. What would it come? Is it such a difficult?
L minus 1 by MUL minus 1.
Okay, so it will come as refractive index that will go on the top of lens with respect to air, and refractive index with respect to medium will come at the bottom. Do we understand this? Yes or no? Everyone understands this? So now remember, this chapter is all about remembering things and using them to the best possible way. Now put a big star on this. Now I can write this formula in this way also, my dear friends. I can write this as focal length in the medium will be equal to focal length in the air, A, refractive index of lens in air divided by refractive index of lens in the medium. Yes or no? You can expect one question from this lens maker's formula. It normally comes in every exam. So this is the same thing written in the form of focal length in the medium is how many times the focal length in air. Do we understand this? Yes or no? No, yes.
Yes, sir. Yes, sir.
Now, if I ask you a question, generally, if I dip a lens in a medium, what happens to its focal length? Does it increase or does it decrease generally? If I put a lens in a medium, say water or some other medium, does the focal length increase or does the focal length decrease? Is the question clear to everyone? Yes or no? No, yes. If I put the lens in a liquid, does the focal length increase or does the focal length of the lens decrease? Yes, can I have your answers, please? And remember that fact.
Decrease, sir.
It will increase, sir. So please remember this. Why will it increase? because if you look at the numerator and you look at the numerator will be more than the denominator. And therefore, the focal length will increase, or you can say in other words, the power will decrease. So note this down as an important point. What happens if you put a lens in a liquid? Generally, the focal length decreases. The focal length increases, power decreases. Please remember this. This chapter is all about remembering simple things in life. If you can remember simple things, you would do astoundingly better in this particular chapter, because this is all about remembering things and using them. All these things that we are doing, my dear friends, they are potential questions that are going to come in the exam. They're all potential questions. Have you noted it down, beta? Any doubts, anyone?
Yes, sir.
Noted down?
Yes, sir.
Shall we move ahead?
Yes, sir.
Okay. Now, there's a very important factor that we have seen on which the type of lens depends on. It depends on the medium which is surrounding it. Yes or no? I've seen many questions on this type, so I'm showing you a tabular form. Normally, what happens is, and this is what happens when you change the medium. Normally, what happens is your refractive index of the lens is greater than the medium. If I have glass in air, refractive index of glass is more than air. Therefore, this lens will behave as convex and this lens will behave as concave. Do you understand this? When I put the formula, I'll show you examples of that as well. If a lens is kept in air or the refractive index of that lens is more than the medium, convex behaves as convex and concave in air behaves as concave. But if I do the opposite, and that is what I asked you, if I put it in a medium where refractive index of that lens is less than that of the medium, that denominator that you saw becomes negative. The denominator becomes negative, concave becomes convex, and convex becomes concave. Here, as you can see, in air it is a convex lens, yes or no? But in the medium, it now behaves as a concave. Why? Because I have kept it in a medium whose refractive index is more than the lens. I've seen many questions of this type come. Please note this down. If you don't want to draw the diagram is not important. The important is the concept. When the refractive index of lens is more than the medium, convex in air is convex in the medium. If the refractive index of the lens is less than the refractive index of the medium, convex in air becomes concave in the medium. Its nature changes. Do we understand this?
Yes, sir.
Then there is a typical case where both of them are same. So I put a convex lens in the same medium from which it was made. Will it behave like a lens? No, it does not behave like a lens. So rays just go parallel. They do not get refracted. It is not a lens anymore. Do we understand this?
Yes, sir.
Please note this down. You may not draw the diagram. Diagram is not important. The thing that is important in this one is to understand the concept behind it. Last bench, do I have your attention, please? Everyone is noting this down, yes or no?
Yes, sir.
Okay, sir, I'll give you 2 minutes to note it down. Have we noted down?
Completed,
No,
sir.
sir.
Okay, I'll wait one more minute, Pacha.
Completed, sir.
Okay, beta, we must give everyone a fair chance. Shall we move?
Yes, sir.
Completed, sir.
Okay, now just to make you understand this concept of which is positive and what is negative, I'm going to discuss a couple of cases here. I hope you understand. And once you get confident, you can solve questions on this type. What you see here is a biconvex lens. Yes or no? Biconvex, both the sides are convex. In the biconvex lens, both the radius of curvature are equal. R1 and R2 are equal. It is known as a equiconvex lens. Have you heard this term, equiconvex lens? Both the radius of curvatures are same. Do we understand this?
Yes, sir.
Now, if I place the object here, this becomes my first surface and this becomes my second surface. Yes or no? Yes or no?
Yes, sir.
The radius of curvature of the first surface will be positive and the radius of curvature of the second surface will be negative. If I write the formula of 1 by f in air, it will be equal to mu minus 1 into 1 by r1. I will put 1 by r, it is positive, minus 1 by r. Do we understand why minus 1 by r? This is your r1 and this is your r2. Do we understand this?
Yes, sir.
Everyone?
Yes, sir.
Now, if you solve this, you can get a shortcut formula. If you want to remember it, you can remember it. It will be r by 2 times mu minus 1. That will be equal to your 1 by f. And 1 by f is nothing but your power of the lens, if you can recollect. So this becomes the power of the lens. Do we understand this? This
Yes,
is
sir.
how you can find out the focal length of any type of lens that comes to you. Got this?
Yes, sir.
Please note it down. Then I'll give you the next.
Completed, sir. Completed, sir.
Okay. What about the next one? What about the other class? Are we done? The other class, we are done. We understand this, what has been done here?
Sir, F equals R by 2 into mu minus 1 or 1 by F equals R by 2 into mu minus 1.
Oh, sorry. I made a mistake. It is F and 1 by P. Sorry. I thought it was written reverse. Sorry. F, which is 1 by P. Sorry. I've written it in the reverse order. So F is equal to R by 2 times mu minus 1. Is it correct now? Okay. Now you can move on to the next case. This type of lens is known as a plano-convex lens. So I've corrected the formula. I written it in the reverse order. Sorry. This is the correct way. Now you have something known as a plano-convex lens. In plano-convex lens, let us say that the object is placed here, my dear friends. So this surface become your surface 1. This is a plane surface, and therefore the therefore the radius of curvature is infinite. Do we understand this? Yes, what happened, beta?
Yes, sir.
Okay. This is the second surface. The second surface has got a radius of curvature r. It is negative, as you can see. Now, if you put the values in the formula, which formula I am talking about, 1 by f will be equal to mu minus 1 into 1 by r1. 1 by r1 is infinity, minus 1 by r. You will land up with the formula that is given. You will land up the formula which is, I think, given here straight away. F is equal to r upon mu minus 1. Do we all understand this? Yes or no?
Yes, sir.
Everyone?
Yes, sir.
Okay, I'll give you one or two more examples so that you get confidence about which one is R1 and which one is R2. Now, there could be a confusion. What will happen if the object is placed on the other side? Have you noted down that?
Yes, sir.
Let us wait for the other class. Have you noted it down?
Not yet, sir.
Okay.
Done, sir.
Okay. Now there might be a confusion, sir. What will happen if the object is placed on the other side? So let me clear it here. Let us say that this is a convex. Oops, why this has become like this? Okay, this is a convex lens. Now in the first case, what I had done was I had placed the object on the left hand side. If I place the object on the right hand side also, nothing changes. This becomes my surface 1 and this becomes my surface 2. This is surface 1. Its radius of curvature would be positive. This is surface 2. This radius of curvature would be negative. If I again put it in the formula, I will again get the same result. Do we understand this? Similarly, if you have a plano-convex lens which looks like this, in the formula that we had seen just now, the object was placed on the left hand side. If I even place the object on the right hand side like this is your surface 1 and this is your surface 2. Surface 1 will now become positive and surface 2 will become infinite. You again put the formula. You again put the values in the formula. You will again get the same answer. Do we understand this? So no matter where the object is placed, you will always get the same focal length. It does not depend on where the object is placed. Yes, it depends on where the lens is placed. If you change the lens and put the lens in some medium, then the focal length changes. Otherwise, the focal length does not change. Am I clear?
Yes, sir.
Everyone understands this?
Yes, sir.
Can I move ahead?
Yes, sir.
Well done, sir. If you understand this, that is the most critical part of this chapter, because we always expect one or two questions coming from this part in the examination hall. And I hope all of you are taking it seriously. I guess so. This is an example of concave lens. The first one is an equiconvex concave lens. If I draw a line and if I place an object here, this is surface number 1, this is surface number 2. Surface number 1, as you can see, is negative. Surface number 2, as you can see, is going to be positive. Effectively, you will get the focal length in this fashion and it will come out as negative. Do we understand this?
Yes, sir.
Nothing. Okay, sir. Sir,
Yes, beta?
understood, sir.
Okay, now the case, take the case of the plano-convex lens. This is just to make you understand that I place the object here. This is surface number 1. This is surface number 2. As you can see here, beta, surface number 1 is having radius of curvature infinite because this is a plane surface. Surface number 2 is positive now. If you put it in the formula, you will again get the same thing. Here they have missed the negative sign, so I'll just put the negative sign. You'll get the same thing, and I think you will get this as mu minus 1, not 2. So they have done a mistake here. Do we understand this?
Yes, sir.
Everyone?
Yes, sir. Yes, sir.
Pakka?
Pakka, sir.
Great. Now, can I give you a full-fledged question?
Sir, can you please wait for a minute, please?
Okay. Note down, don't worry. See, you must understand that this is the most important aspect of this chapter. I'm expecting a question from this aspect, and therefore, take your time unless and until you are confident, because after this, nothing is left. After this, there is only lens formula, and that's it. We are done with the chapter. Only lens formula, and then different cases. If I cut it like this, what happens? If I cut it like that, what happens? Understand this, everything is simple. Take your time. Feel confident.
Completed, sir.
Completed, sir.
Okay, well done. Then this is a question from your sheet, from your module only, self-practice problems. Question number 27. If you have that sheet, you can have a look at it. Question number 1, it is a straightforward question. Let us first begin with this. Find the focal length. Everything is being given here. To find the focal length of a double convex lens. So everything is given. R1 is given as 15, R2 is given as minus 25, refractive index. Normally the refractive index of glass is given as 3/2, even if it is not mentioned, you can take it as 3/2. You have to find out the focal length of this lens. Normally a question that is going to come in the exam will not be in this form, it will be in the form of a diagram. We'll do it just after this, but first let us get over this one so that we can settle some nerves. Let's see who gets it first. Everyone was noting it down first. Let us see who gets the answer first. And I don't have the answer, so I can't tell you what is correct or wrong unless until I solve it. 2 minutes you have.
Sir. 75/4, sir.
Great, I have an answer. I can't tell you whether it is correct or not.
75/4, sir.
Okay, so I'm getting the same answer from 2 different people sitting in 2 different classes. That means it has to get checked. So let me put the formula. The formula that I have is 1/f is equal to mu minus 1 into 1/r1. Let us get used to this formula. Minus 1/r2. I put the values. 1/f. The value of mu is 3/2. 3/2 minus 1. Then I see what is the value of R1 and R2. They have given them with sign, so I don't have to even worry about this. 1/15 minus 1/25, and I hope you can calculate this small thing. 3/2 minus 1 is half. can calculate the rest. What is the answer for focal length coming?
25 by 4.
75 by 4, sir.
By 4 with a positive sign. That means it has to be a convex lens, double convex lens for that matter. And that is the answer we got. Everyone got the same answer? Yes or no? Can I have raised hands from everyone? All girls, all boys, well done. This is what I call democracy. Everyone getting the same answer. That is not democracy, but that is looking good. It may be called as dictatorship. Everyone getting the same answer, but it's a good sign that we have got the first one. And again, I'm taking a same question from your sheet only, from your module only. So if you have the module, you can check it in the module and do it from the module itself. The question goes like this. I think this is question number 47 from your module. So best of luck. This is the question. This is how questions are going to be. They're going to give you a diagram. Then they are going to give you some information about the diagram. And then they are going to ask you find the focal length. It's a very, very, very common question. It has come multiple times in multiple exams. I hope you can get rid of this. Find the focal length of lens that is shown in the figure. From now onwards, I will not show you this. I will just show you a diagram and I'll ask you the answer. So ROC means radius of curvature, 10 centimeters, mu is 1. So on both sides, we have air. In between, I have a sandwiched lens whose refractive index is 3/2. The more you do these type of questions, you will understand that as soon as you see radius of curvature is 10 centimeters, same on both sides, and as soon as you see that the refractive index is 3/2, you will give me the answer in a flash, and the answer is
3.
3. How did you get 3? Remember what I said. As soon as you see a double convex,
5/2, sir.
as soon as you see a double convex lens,
10, sir.
yes, 10, sir. As soon as you see a double convex lens, remember this, as soon as you see a double convex lens, and as soon as you see the refractive index is 3/2, your answer is equal to R. F is equal to R. You will always get it. Do you understand this? The more
Yes,
the number
sir.
of times you do this, the more the number of times you will do this, you will get this. We understand this, everyone, bacha? 1/f is equal to mu minus 1 times 1/r1 minus 1/r2. I can do it 15 times, 100 times. I will still get the same answer. So 1/f will be equal to mu is given as 3/2. 3/2 minus 1 is half. So 1/2 will come from here. 1 by plus 10 minus 1 by minus 1/10. So it will become 2/10. 2 and 2 will get cancelled. And eventually you will get Fs plus 10. Do we understand this? Yes or no? No, yes.
Yes, sir.
You have to be fast. You have to be fast. The reason that we are doing this is that you get used to this and you can tell me the answer in a flash, because that may not be the question. The question may be they would place an object here and they will tell you where is the image form. So finding out the focal length can be just one of the steps of the problem. And I don't want you to waste time on that step. If you can calculate it quicker, you can save a lot of time for the other question. And now I'm not giving you the question, I'm just showing you the diagram. And I ask the focal length of this gentleman, and the answer is
-10, sir.
Minus 10, sir.
and the answer is -10. So you don't have to calculate it. Once you get used to it, you will understand this is a double convex, double concave lens. Everything is same. It has to be minus 10 centimeters. Do we understand this? This is how you become fast. You just use what you have learned. And how do you learn it? You just learn it by doing a lot of practice. That's it. Here comes the next question. Let us, and this is just to clear your any doubt that you might have. What happens when light comes from the left hand side? What happens when light comes from the right hand side? And this is a question number 49, I think it is. From your sheet, can I have the answer? Find the focal length of the lens shown in the figure. In first case, light is falling from the left hand side. In the second case, light is falling from the right hand side. I asked you before solving this question, will the focal length change left hand side or right hand side?
No, sir.
It will come same. You can check it. So you just have to do it for one side. Once you do it for one side, you are done. I have forgotten the question. I will call it question number 4. Let's see who gets the answer first. Yes, beta.
Sir, A minus 60.
Minus?
60,
Minus
sir.
60.
Minus. The module that I have it says plus 60. It may be wrong. Not a problem. There can be printing mistakes here. So let us solve it. So let us take light incident from the left hand side. So this is the object. This becomes my surface 1. I'll have to be careful. This becomes my surface 2. Let me put the formula, my dear friends. 1 by f will be equal to mu minus 1 times 1 by r1 minus 1 by r2. I just put the values now. 1 by f, the value of mu is 3 by 2. 3 by 2 minus 1 is half. So let me just put half. Do we understand this now? Why should I put it again? 3 by 2 minus 1 is half. Yes or no? Let us look at R1, the first surface. Is it positive or is it negative?
Positive.
Look at the surface. Look at the surface.
Negative, sir.
It is concave, beta. See, the surface looks like this, and light is coming from here. It is concave, no, bacha. Yes or no? Huh? Yes or no? Okay, sir. So minus 1 by 60 minus. Look at the second surface. Light is coming from here. Look at the second surface. Positive or negative?
Positive, sir.
Negative.
It's negative, beta. Look at the surface. Open your eyes. Open your eyes, my dear friends. I will show you the surface again. Bigger diagram. See the universe.
Negative, sir.
Sir, the universe is beautiful, sir. The 4% of which what we see, sir. It is beautiful, sir. Please see it in that way, sir. Open your eyes. Look at the bigger diagram. This is a bigger diagram. The same thing. Look at what we have here. If I come from here, this surface is concave. Yes or no? The other surface, light is coming from here. The other surface is also concave. So both are negative. Yes or no?
Yes, sir.
You all understand this?
Yes,
Yes,
sir.
sir.
Both the surface are concave, my dear friends. So I move and put the values again. Minus 1 by 20. Now can you solve this and get me the answer, bacha? What is the focal
Sir, it's
length?
plus 60, sir.
Plus 60?
Yes, sir.
So this is a convex lens.
plus 60.
This is a convex lens. This type of lens is known as concavo convex. Do we understand this? Concavo convex. Concavo convex. Concavo convex.
Sir,
Okay.
B is minus 60.
Just now I asked you if I look from here or look from there, it will come
Same,
same,
sir.
no? It will come same, no? Okay. If I look from here or look from there, it will come same, bacha. Now let me change it. Come to the diagram, let me change it. Now the object is placed here, let us say. Let me take out that blue thing away. Take out that blue thing away. Now the object is placed here. This is surface number 1. This is surface number 1. Is the radius of curvature positive or negative? Yes?
Positive, sir.
Positive. Well done. Positive 20. I think 20 was that. Look at number 2. Is it positive or negative?
Positive, sir.
Positive.
But there is a negative there, so it becomes minus 1 by 60. We end up with the same answer, sir. Whether I look from here or look from there, the lens remains same. Will you remember it? Yes or no? No or yes?
Yes, sir.
Pakka,
Yes, sir.
pakka, pakka and kacha pakka. What type of pakka is this?
Pakka, pakka.
Pakka, pakka, na?
Pakka, pakka, sir.
Do we understand this, beta? That is what I mean to do by this thing, that you must be able to understand from wherever I see, wherever I keep the object, the focus, the focal length, or the nature of the lens does not change. When I was of your age, I also thought the same thing, that if I look from here, it will be concave. If I look from there, it will be convex. But then with time, I understood that that is not the case. Are we ready for the next one?
Yes, sir.
Then, sir, this one, sir. Let us see who gets me the answer, sir. You have an option here also, because this is taken from one of your previous JEE main paper. Best of luck. I've forgotten the number of question. I'm writing question number 6. The power, the power of a thin convex lens whose refractive index is 1.3 is 5 diopters. When it is placed in a liquid of refractive index A mu L, whatever, mu, you can call it mu, then it behaves as a concave lens of focal length 100 centimeter. What is the refractive index of the liquid? I'll give you 2 minutes to solve this.
Satya. Satya.
Sure.
We have an answer.
Ask them to
Yes, beta.
ask them to mute, sir.
What happened?
They are disturbing the class and unwantedly they are calling other names.
What is happening? I don't understand.
Other class members are calling our class member names, sir.
Well, I hope that this thing is not repeated. Can I hope that? I hope we are here to study. Yes or no, beta? And I hold all of you in high regards. Yes or no?
Sir, we are muted only, sir.
So who is saying what then? Maybe someone from outside came and said something? Okay. Let's not indulge into all those things. That is not good. I hope you all concentrate on the class here, right? Are we there?
Yes, sir.
Okay. Please concentrate on the question. The question is there for you to solve. Please concentrate on that. Okay, I think there was someone who came in the room and he was saying something. I don't know. Okay, let's concentrate on the question. Do we remember the question? The power of a thin lens is +5 when it is placed in air. When it is placed in some other medium, it behaves as a concave lens. With a focal length of 100 centimeters. What is the refractive index of that medium? Will it be more than the lens or will it be less than the lens? Tell me that.
More than the lens, sir.
Well done. It will be more than the lens. Good. So we are good on one aspect. Now can I have the real answer?
We are doing it, sir.
Okay, I'll give you time. And I hope mischievous things don't happen in the class. I don't appreciate it. Okay. Because then I'll ask the office people to come and sit and take some severe actions which I don't want. Okay. I hope I hope my message is clear to everyone, bacha. Solve the question. Shall I solve the question for you, beta? If you're finding trouble? Yes or no? Okay. So which formula we have to apply here? Focal length in the medium divided by focal length in
In the
air.
air equals to
Well done.
uh,
Mu of the lens in air.
minus 1 by mu of medium
Lens mu of
minus 1
lens, mu of lens in the
lens.
medium, beta. Remember that, है ना?
Okay,
Minus
sir.
1. That is the thing that you might be making a mistake here. Let us see what all things are given to me. Focal length of the mirror is given as 100 centimeters. Yes or no?
Yes, sir.
Focal length in the medium, sorry. Focal length in air, you can find out from the power.
1 by
Power
20,
is
sir.
given as 5 diopter. So you can find out the focal length in the air, bacha. Tell me
20,
what the
sir.
value, what value is coming? Focal
20
length, 20 centimeters or meter, bacha?
centimeters, sir.
Well done. See, you are so good kids. I'm so proud of everyone. 20 centimeters. Let us put these values first of all here. So remember, in the medium, it is behaving as a concave lens. So we must remember that. So that will be minus 100, yes or no? Divided by 20. Minus 100 divided by 20. That should be equal to refractive index of the glass or the lens with respect to air. How much is that given, bacha? It is given as 3 by 2.
1.5, 3 by 2, sir.
Okay, 3 by 2 minus 1 divided by, you just have to find out now, refractive index of lens with respect to the medium. You must remember that formula. Refractive index of lens with respect to the medium will be equal to what, bacha? Tell me. It will be the refractive index of lens divided by refractive index of the medium. Yes or no?
Yes, sir.
So I can write it as 3 by 2, which is the refractive index of medium divided by mu. This is the mu that I have to calculate. So I'll just put it here, dear. 3 by 2 divided by mu minus 1. So on the left hand side, I have minus 5. On the right hand side, in the numerator, I have 1 by 2. I leave it at this. And I ask you to solve it. You can do this, na? This is a simple calculation, bacha.
Yes, sir.
Can you tell me the answer, dear? Can I have the answer, bacha?
Five by three, sir.
Well done. 5 by 3. That is the correct answer. Well done. Everyone got this? Yes or no?
Yes, sir.
Good. I'll give you 1 minute. Why it was taking so long for you to solve it? Please tell me. I did not think that it was such a difficult question that it takes so much of time. Can you tell me what took you so long? Want to tell me what took you so long? Or no? At what part you were confused? If you tell me at what part you will confuse, I'll be able to put the next question in a similar way so that the confusion gets clear. If you don't tell me, I will just do it by my own way. So I would be glad if you can tell me, sir, we got confused here. So anyways, have you noted it down, everyone?
Yes, sir.
sir.
This is the next question. It has come many times in JEE. It's a very old question, and I hope that you can solve it with your own hands. The question is like this: a double convex lens made up of a material refractive index 1.5, mu is always 1.5, and having a focal length of 10 centimeter is immersed in a liquid of refractive index 3. The lens will behave as, will it behave as a converging lens or will it behave as a diverging lens, my dear friends?
Diverging, sir.
Well done. So you understand that the medium is more than the refractive index of the lens. It will change its nature. Concave become convex. Well done. Convex becomes concave. Can I have your answers, please? Remember, simple things. If you do them correctly, beta, no one can stop you from achieving your goal. No one can stop you from achieving your goal.
B, sir.
Diverging lens of focal length 10/3. This is the answer we are getting.
Yes, sir.
Okay. Just give me a minute. Okay, I was looking at the next question. Yes, the answer is
B, sir.
the answer that I have shows A. What's wrong? Must be something that I missed. Remember, if you do simple things correctly, my dear friends, we would do a lot better. Shall I do it or you want to try again?
Yes, sir.
You want to try again or shall I do it better? I did not get you. You want me to do it for you?
We'll try it, sir. 1 minute.
Okay. Okay. Try it, beta. I really want you to do it. The more the questions you do, beta, the more confident you will become that you can solve any question which comes on this category. I just want you to get that confidence, nothing else. I have no hidden agenda. The only hidden agenda that I have is that you should be confident of any question that comes in this type, because I don't know, I feel that this strong feeling that you might get a question. You might get a question from this type.
Sir, option A.
Option A, at last. Someone got the answer. Okay. Give you 1 more minute. So how are we supposed to do this? The formula we all know, focal length in the medium divided by focal length in air is nothing but refractive index of lens with respect to air minus 1 divided by refractive index of lens with respect to the medium minus 1. Now let us find out the focal length. Let us solve this. Refractive index of lens with respect to air is 1.5. 1.5 minus 1 is going to be half. So let me write it as half straight away. Let's not waste time in that. Refractive index of lens with respect to the medium, it will be the refractive index of the lens, which is 1.5 divided by refractive index of the medium, which is 3. Yes or no?
Yes, sir.
Minus 1. And remember, the focal length in air is given as 10 plus 10. This is given as plus 10. If you now put the values correctly, what I see is you get the same answer, but you get on the right hand side, you get minus 1. Are you getting minus 1? Yes or no? So the final answer will be coming as minus 10 centimeters. Do we all understand this?
Yes,
So
sir.
a lens which was a EQ convex lens of focal length plus 10 centimeter now behaves like a concave lens of the same focal length. And why this has happened? This has happened because it has been placed in a different medium whose refractive index and other things were in such a way that it changed it from a convex into a concave. I'll give you one last on this.
Completed, sir.
Written it?
Yes, sir.
Sir, 1 minute, sir.
Okay.
Completed, sir.
Okay. Can I give you the next question?
Yes, sir.
Here comes the next one. Let's see who can do this. A bit of a tricky one. I forgot the question number, so I'll call you one number one. There is an EQ convex lens with radius of each face as r. Mu of that is 3 by 2. Mu of water is 4 by 3. If there is water in the object space and air in the image space, oops, what is the focal length of this gentleman? The question. So if I draw this one, and you might encounter a question like this in probably JEE Main, it can also come in JEE Main as well advanced. So what is happening here is I don't have same medium on both sides. My lens does not look good, but I hope you can understand it. Here I have water. Here I have air. In between, I have glass. If there was water on both sides, not a problem. If there was air on both sides, not a problem. What is the focal length of this now? One side is water, other side is air. Now the scenario changes. Do we understand the question? If there is complete water outside, we have the formula that we use. If there is complete air outside, we have the original formula that we use. If I have water on one side and air on the other side, what happens? 2 minutes. You have solve it. Remember, whenever we are talking about focal length of the lens, which focal length are we talking about? Wherever we have found out all these
Second
focal.
focal length. Second principal focus.
Well done. And remember, what do you mean by second principal focus? What is second principal focus? Do you remember it? Which point is the second principal focus? Yes.
Right side.
What sort of answer is this? Second principal focus is right side. What is this? Did I ever say? The second principal focus, my dear friends, is the focus on the right side. And the first principal focus is the focus on the left side. Did I ever say this way?
No, sir.
I gave you a definition, my dear friends, and this is where the definition comes into the picture. Because if you remember this definition, you should be able to crack it.
When a parallel lines passes through a mirror and converge
Mirror?
at focus.
Mirror.
Sorry, lens.
Yes. Repeat again.
Parallel lines which passes through lens and converge at focus is known as second principle.
So I should have parallel lines, parallel rays. When this parallel rays after refraction from the lens, whatever point they converge, that point is known as your second principal focus. Do we understand this?
Yes, sir.
Yes, sir.
That is how you will have to calculate this, gentlemen, my dear friends. How many refractions are happening? 2. 2 refractions are happening. Object side, there is water. Image side, there is air. That means my object is here. Do we understand this? Yes or no? My object
Yes,
is here.
sir.
And my image is supposed to be formed here. You have to calculate the second principal focal length of this combination. How are you going to do this? I'm going to take 2 refractions. What is the first refraction? It will happen from this surface. Do we understand this?
Yes, sir.
Can I have raised hands from everyone that we understand this? Now, which formula I'm going to apply? This is not a lens now. This is just a curved surface. Do we understand this? So I'll
Yes,
apply
sir.
the formula, that original formula, mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. Do we understand? Let me now put the values. What is the value of mu2? Go back. Tell me what is the value of mu2. Tell me what is the value of mu2.
1.
Are look
3
at
by
the
2.
surface. Look at the surface. Look,
3 by 2,
look
sir.
from where instant ray is coming. Look where
3 by 2, sir.
4 by 3, sir.
3 by 2, sir. 3
3
by
by
2.
2, sir.
Arey 3 by 2.
2.
Look at the second medium, bacha. 3 by 2. 3 by 2 divided by. Now this surface will create some image. Let me call this as I dash. Do you understand the meaning of I dash? This is the image that this creates, and I call this as V dash. So 3 by 2 divided by V dash. Do we understand this? It is creating the first image. Okay, what is the value of mu1?
4 by 3.
4 by 3.
What is the value of u? From where are the rays coming? I want to find out the second principal focus. Where are the rays coming from? They are coming from They're coming
Infinity.
from infinity. Do we understand this?
Yes, sir.
That must be equal to mu2 is 3 by 2 minus mu1 is 4 by 3 divided by r. Is this radius of curvature positive or negative? Look at the first surface. Is this radius of curvature positive or negative?
Positive.
R. This is my equation number 1. This is my equation number 1. This is my equation number 1 for the first surface. From here, I have to calculate the value of V dash, the first image. Can you tell me what is the value of V dash from here? The value of V dash from here is going to come as 9R. Now, this image will act as an object for the second surface. Do we understand this? Yes? No.
Yes, sir.
Now, remember, this is a thin lens. This is a thin lens, and that is why this is a thin lens formula. If this is a thin lens, I know that the first distance is coming from this point, but since it is a very thin lens, I can assume that the same distance is from this point. So this V dash will now act as object distance for the second surface. Do we understand this? Remember, this is a thin lens. Do we understand this?
Yes, sir.
Now I apply it for the second surface. Same formula. I'll write the formula. Mu2 by V minus mu2 by V minus mu1 by U will be equal to mu2 minus mu1 divided by R. Now, fatafat, tell me what is the value of mu2. Remember, refraction is happening. The ray is inside glass now, and it is going to air. Yes. What is the value of mu2?
1, sir.
1 divided by V minus, what is the value of mu1?
3 by 2, sir.
Well done, 3 by 2. Now be careful and tell me what is the value of U. Be careful. Tell me what is the value of U. Just carefully.
V dash, sir.
V
Nine
dash
9R.
9R. Plus or minus? Plus or minus? Plus or minus? Last question.
Minus.
Plus or minus? It will remain plus only. Yes or no?
minus 9 we are.
No, beta. It is still in the distance is still measured in the same direction. Do we
Yes.
understand this? So it still
Yes,
remains
sir.
plus. Okay, well done. That will be equal to, now it is very simple. 1 minus 3 by 2. Again, be careful. What is this R? Is it positive R or negative R? Look at the second surface, bacha, now. Look at the second surface now.
Negative R, sir.
Well done. Well done. Very well done. From here, you will get the value of this V. And what will this V give us? This V will give us the point where parallel rays are going to converge. So this V will become equal to what? This V is the point where finally, after 2 refractions, rays are going to converge. So what is this V? This V is effectively your second focal length. Yes or no?
4F, sir. Focus, sir.
It will be your second principal focus, and the value of V will be the second principal focal length. I give you this as homework. The answer for the second principal focal length will be coming as 3 by 2R. In the next class, I'll give you one question on this again, which you will have to do with your own hands. Do we agree on this? Yes or no? No, yes.
Yes, sir.
Have you understood the concept? The concept is very simple. Whenever someone asks you the focal length of a lens, we are talking about the second focal length. How do I get the second focal length? We have to remember the definition of second focus. Parallel rays of light after refraction at whatever point they come, that is the second principal focus. How did I find out the second principal focus here? One side, object side, I had air. Image side, object side, I had water. Image side, I had air. I took first refraction from the first surface from water to air, from water to glass. Then I took the second refraction from glass to air. In case of first refraction, the light were coming from infinity. So U was infinity. When I get the value of V from the first surface, I took it as U in the second one. And that is how I calculated the final V, and that final V has to be at the second principal focus. Do we understand this?
Yes, sir.
The next class, I'll give you one more question on this. We'll wind this up. Then we'll look on to the lens formula, and then the rest of the things are pretty straightforward. If you understand this, this is the most difficult aspect of this chapter. If you understand this, then everything looks good. Everyone has written this down, yes or no?
Yes, sir.
That brings us to an end of this class, sir. May God bless all of you. And I hope that you study and do less mischief in the class. Take care. Have a nice day. God bless you all.
Okay, sir. Tata, sir.